Hello guys, this is Neha from Edureka, and in this session I will help you compare two major big data platforms, that is Hadoop MapReduce and Apache Spark. We are going to use few parameters like performance, cost, ease of use, data processing, security and fault tolerance that will be the benchmark for our comparison. Before I differentiate these terms for you guys, let me first tell you about the current stats of these trending frameworks. According to the market research by Forbes in 2017, big data adoption reached 53% in the IT industry. Out of that, Spark overtook the big data adoption rate by 47%, whereas MapReduce took only 14% of the market. So current market stats is not the only metric through which we can compare these two frameworks. In today's hyper-growing industries, Spark and MapReduce play their own role to benefit us with its features. So guys, let's explore the various other parameters through which we can compare these two frameworks. The first on the list we have is performance. As you can see in this picture, in case of Hadoop MapReduce, the data moves between disk and network. But in case of Spark, the data is cached in the memory. So now let me explain this to you. Hadoop MapReduce passes data back to the disk after a map or reduce action. But Apache Spark processes data in the memory. So let me tell you one thing. Spark needs a lot of memory. Much like the standard databases, it loads a process into the memory and keeps it there until the further notice. On the other hand, MapReduce, however, kills its processes as soon as the job is done, so that it can run easily alongside other services with minor performance differences. So I can say that Spark performs better when all the data fits in the memory. So consider an example where you want to store 32 GB of data and the RAM size that you have is just 16 GB. So what happens when the data size is more than the size of the memory? In case of this, when the memory is full, Spark automatically starts using the disk space to store the data. So this is how Spark performs better when compared to Hadoop MapReduce. Now let's move further and see ease of use. Talking about Spark, it has comfortable APIs for Java, Scala, Python, and also includes Spark SQL for the SQL savvy. It's very easy to write user-defined functions as it has enriched APIs and that supports interactive mode in real time. On the other hand, Hadoop MapReduce is written in Java and is infamous for being very difficult to program. Though you have Pig that makes it easier, it requires some time to learn the syntax. And one more thing to tell you, Hadoop MapReduce does not support real-time data processing. So one can say that Spark is easier to program and includes an interactive mode. On the other hand, Hadoop MapReduce is more difficult to program, but it is very useful for batch processing systems. Next, let's see how cost influences both Hadoop MapReduce and Apache Spark. To tell you, both are open source, but money needs to be spent on machining and staff. In case of Spark, the memory should be at least as large as the amount of data that you need to process, because the data has to fit in the memory for optimal performance. So if you need to process really big data, Hadoop will definitely be the cheaper option since the hard disk space comes at a much lower rate than memory space. Not only that, there is also a wide array of Hadoop as a service offerings and Hadoop-based services which will help to skip the hardware and staffing requirements. So based on these considerations, I can say Spark is more cost-effective according to the benchmarks, whereas Hadoop MapReduce could be cheaper as it provides Hadoop as a service offerings. But yes, one important thing to keep in mind is that Spark's technology reduces the number of required systems. That is, it needs significantly few systems that actually cost more. So there will be a point at time where Spark reduces the cost per unit of computation even with the additional RAM requirement. So in this case, both are actually having their own cost benefits in their own ways. Now coming to data processing, Apache Spark can do more than plain data processing. That is, it can process graphs and use the existing machine learning libraries. Not only that, Spark can also do real-time data processing as well as the batch processing. This presents an interesting opportunity to use one platform for everything instead of having to split tasks across different platforms. On the other hand, Hadoop MapReduce is great for batch processing. If you want a real-time option, you will need to use another platform like a Storm or Impala. And for graph processing, you can use Giraffe. So by this, we can say that Spark is a Swiss Army knife of data processing, whereas Hadoop MapReduce is a commando knife of batch processing. So let me tell you, if you want to process real-time data with 100 times faster than MapReduce, then you can opt for Apache Spark. And if you just want to do batch processing or plain data processing, you can go with Hadoop MapReduce. Now let's see how both these frameworks play a fair role in case of security aspect. Coming to Spark, it is bit bare at the moment when it comes to security. Authentication is supported via a shared secret, and the web user interface can be secured via Java X servlet filters, and event logging is also included. Whereas Hadoop MapReduce can enjoy all the Hadoop security benefits and integrate with Hadoop security projects like Knox Gateway and Sentry. So I can say in terms of security, Spark is still in its infancy, but Hadoop MapReduce has more inbuilt security features and projects. As MapReduce is very old in the big data playground, I can say in case of security, Hadoop MapReduce is a pro, whereas Apache Spark is a learner in terms of security in the big data playground. Now let's look at the last parameter, that is fault tolerance. Talking about Spark, it has retries per task and speculative execution, but MapReduce relies on hard drives. I can say if a process crashes in the middle of execution, it could continue wherever it is left off, and this can actually save time. That is, we can say it uses replication for fault tolerance. In case of Spark, we all know that the resilient distributed data sets are the building blocks of Apache Spark, and they provide the fault tolerance to Spark. They can refer to any data set present in the external storage system like HDFS, HBase, shared file system, and many more. And they can then be operated parallelly. One interesting thing to know is that RDDs can persist a data set in the memory across operations, which makes future actions 10 times much faster. So if an RDD is lost, it will automatically be recomputed by using the original transformations. This is how Spark provides fault tolerance. Now that we have compared MapReduce and Spark based on these parameters, let's see a real-time example of each of them. First, let's see a use case of MapReduce. So now let's see how MapReduce is used in ETL and data analytics, that is extract, transform, load, and data analytics. MapReduce programming can be used to transform data, files, or records from one system to another using distributed models. Say you have two data centers, one is located in Europe and the other one in US. And you have 10 terabytes of data in data center 1, and you want to transform all the data to data center 2. So if you try to extract, transform, and load all these files from data center 1 to data center 2 using the traditional way of bulk copy, do you think it will work? An obvious no, right? So in this case, MapReduce programming model plays a vital role to build a distributed system for copying files from data center 1 to data center 2. We can use the map function to locate a specific file and then break it down into chunks for transfer, while the reduce function can combine the chunks of a related file and then perform checksum to ensure data integrity and so on. We can use MapReduce programming for analyzing large volumes of data from databases, data warehouses, or logs while implementing specific business logic to derive insights. It can also be used for building extract, transform, and load systems, that is ETL systems, for moving data from one data store to another. So this is how MapReduce is useful for ETL and data analytics. Now let's see a use case of Apache Spark. So let's try to understand how Spark is used in credit card fraud detection. Credit card transaction can be captured over time based on the behavior of the cardholder spending incidents. The events are stored as transaction history, which would be used to analyze the possible detection of fraud. The big data fraud detection techniques analyze the data to find out the relationship between the historical data and the data which is learned over the period. The techniques will help in extracting meaningful evidence of frauds from large data sets. In this example, let's consider the credit card holder is from India and all the transaction is above the spending limit and the transaction is made in US. The stream of data is injected through the Kafka through various topics and is processed in the Spark engine. It is then analyzed to detect the fraud, which is written to the fraud topic. If the transaction is over the limit of regular spending or if the transaction is made in a different city, then the transaction is written to the fraud topic. So now let me tell you what happens in Spark engine and how does Spark streaming works. Spark streaming can process unstructured and structured data. Spark reads all the data straight from a file and converts it to a resilient distributed datasets, that is the RDDs. Spark streaming receives the data streams and splits data into batches. After the division, data is processed by the core of the Spark, that is Spark engine, which will generate the final stream of results in batches from the specified interval of time, which is called as windowing. When these streams of the data come to the Spark streaming as D streams, that is the decriticized stream, they are sequenced internally as RDDs. The RDD operations are performed in parallel when the credit card data is passed to get the necessary information. So in this case, events that are related to fraud are published to fraud topics, and likewise, non-fraud events are published to enrich topics. So this is how Spark is used to identify the fraud topics in credit card fraud detection. Now that we have analyzed and compared all the factors of MapReduce and Spark, let's answer the burning question that is there in all of your minds. Which framework to choose, Hadoop MapReduce or Apache Spark? Well, to give you a tailored response, I would say it's your particular business needs that determines the choice of a framework. Linear processing of huge data sets is the advantage of Hadoop MapReduce, while Spark delivers fast performance, iterative processing, real-time analytics, graph processing, machine learning, and many more. In many cases, Spark may outperform Hadoop MapReduce. The best part is that Spark is fully compatible with the Hadoop ecosystem and also works smoothly with Hadoop distributed file system, Apache Hive, etc. By this analysis, I can conclude that Apache Spark is the shiny new toy in the big data playground. But for batch processing applications, MapReduce still plays a key role in its field. So which framework do you think is the winner? You can put your choice of winner in the comment section below. That's all for the session. Thank you and have a nice day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!